So the next topic which we are going to discuss is construction materials. What are the different construction materials and what are the properties of it? Okay. So the first material, which the basic material is concrete. Okay. So concrete is made up of cement, sand, and aggregate. Okay. Plus to bind them, we need to add hydration to it. We add water into it. Okay. So concrete is made up of cement, sand, and aggregate. So and we add water to mix it to make it workable. Okay. Now these are the four components which go inside the concrete, which you can see in the slides. I have made this diagram, which where you can see that concrete is made up of cement, sand, and aggregate plus water. Now there are different properties. See, at first we will understand what are the purpose of different materials here. Okay, so for example, sand is the binding property. Okay, it will bind all the materials together, right? Whereas your coarse aggregate and fine aggregate, right, will give a certain amount of strength and it will fill the gaps, right? And the water will help you in workability. Okay, to mix it, right, to do the heat of to start the process of hydration, we need water. Okay, now this concrete, okay, now what you need to know is while calculating the amount of materials for the concrete. Okay, so suppose if you have you need to make a slab. Okay, the slab is, say, suppose 1 meter by 2 meter, or take it 2 meter by 5 meter. Okay, so 2 meter by 5 meter slab, that is total area of the slab is 2 into 5, 10 meter cube, right? So total area of the slab is 10 meter cube, and so suppose its depth is 15 centimeter, that is 0.15. So 10 into 0.15, it is 1.5 meter cube of concrete you will need. But that is wet concrete. To calculate dry concrete, you need to multiply it by 1.54. Okay, that's how you will calculate dry concrete. Now you need to also understand dry volume is bigger than wet volume. Okay, or dry volume is more than wet volume, because once you add water, the sand and cement will come close together, the voids inside will get filled with water and they will come close together and the volume will reduce. Okay, so this is the basic idea. That's why we multiply it by 1.54. 54% increase is there in general. Okay, so we multiply it by 1.54 and we find out dry volume. Now this dry volume, how you will use this dry volume is you need to know the grade of concrete. Okay, so suppose if you are using M15 grade, so for M15 grade the mix ratio is 1:2:4. The basic idea, the basic grade M15 1:2:4. That means this 1:2:4 means 1 part of cement, 2 parts of sand and 4 parts of aggregate. Okay, so that you need to remember: 1 part of cement, 2 parts of sand and 4 parts of aggregate. If you take any other grade, say suppose M20 or M25, right? If you take any other grade, it will have its own mix ratio. Okay, some will have 1:1:2, 1:1.5:3. Okay, something like that. So the first part is always cement, the second part is your sand, and the third part is your aggregate. Using this, you can find the volume of different components. Say suppose you got volume of cement, you can calculate volume of cement, you can calculate volume of sand, you can calculate volume of aggregate. Then this volume you can convert into weight. Okay, so suppose this volume, how you can convert volume into weight? The basic idea is the properties which we have studied. One property was density. Density was mass by volume. So what you can do, mass divided by volume. Okay, so I will write it on the screen, just you can see. Density rho is not but just a second, yeah. So density rho is nothing but mass by volume. Previously, using your what we say mix ratio, that was 1:2:4. 1 was for cement, 2 was for sand and 4 was for aggregate. Okay, so using this we found out individual volume, right? Once we found out individual volume, that is cement and aggregate, okay, we can use this volume here. Okay, so what we need to know? We need to know density of cement. Once we know density of cement, we know volume of cement, we can find mass of cement. Once we have the mass of cement, what we can do here is, once we have mass of cement, we know weight is nothing but mass times gravity, right? So we can write weight is nothing but mass, whatever you got, times gravity is 9.81, you will get the weight. So suppose total weight you required around 200 kg. Okay, if suppose it comes out to be 200 kg. Okay, so if you get the total weight, okay, what you can do is you can just divide it by one bag of cement. Okay, one bag of cement is nothing but 50 kg cement, right? So what you can do, you can divide it by 50, right, and you will get the number of bags required for the site. So this is the basic idea. So what I was trying to tell you here is concrete is nothing but a mixture of cement, sand, aggregate mixed with water. Okay, so you can find out the quantities, okay, very easily. Okay, now cement, property of cement here is to bind the entire your concrete. It has a binding property, whereas aggregate and sand are used to mix with the cement to get its desired strength and texture, and then water is used for the hydration process. Okay, so this is all about your concrete. We will also look through different materials. The first material we have talked about concrete. Okay, now here are the few mixed ratios by weight. Okay, so this table you can go through later and see what are the different mixed ratios according to the weight. Okay, mixed ratios by volume also is given. Okay, so this table gives you mixed ratio by volume. Okay, now this concrete generally can be classified as well graded concrete and poorly graded concrete. Well graded concrete is where you have molecules of all sizes. Okay, see here you have small molecules, bigger molecules, right? So if you have molecules of all sizes, we say well graded. And if there are only one type of molecule or two types of molecule, and we have missing molecules, smaller molecules if they are missing, or if suppose bigger molecules they are missing, right, then we say poorly graded. Now we prefer well graded over poorly graded. Okay, so we need all types of molecules, small size molecules, larger size molecules, okay, so that it can be well graded, so that there is no empty space, there are no voids in the concrete. Okay, empty grades, voids will result into lesser strength and your building might collapse. Okay, so that we are trying to avoid.